Okay, so this is mechanics term one, term two, week one, CA. We're gonna go through it a bit fast because, well, you know. So we have this question. It always comes with the same number, 25, but oh, these settings are very bad. Anyway, so this one always comes as 25 in the exam, but we're gonna explain it. So we have our mass M attached to the trolley, right? And they're saying that it shouldn't slip. So its net force should always be equal to 0, right? So here's the thing: we need to write, we need to draw our FPD so that we kind of know what we're doing. We have our mass M. We're gonna start with the y-axis, and we're gonna draw our x-axis, right? Okay, type. We obviously know the weight is going downwards. Let's change our color. Go to, I don't know, red. W, right? Okay. We know that the friction is acting upwards, preventing it from sliding down, right? And then you should always have a normal because it's perpendicular over here to the surface, as there's a surface. Anytime you have a surface, there is a normal. So we have normal over here. So we know that sigma f. Wait, hold up. Wait. I messed up. I don't know what I'm doing. It's correct. What I was doing is correct, but I forgot that I didn't read the question. It's accelerating to the right. So actually, sigma fx is going to be equal to ma, right? Since it's accelerating. But sigma fy is going to be equal to 0. I don't know why I'm starting with this. I should start first with FPD, which was correct. FPD was correct. I'm not going to label my axis, guys, because خلاص كلها CA. I don't want to waste my time. فعندك الويت going down، عندك الفriction going up، وعندك الnormal to the right. Yeah, we know it's accelerating to horizontally, obviously. So sigma fx is going to be equal to ma. Sorry if the handwriting is bad, huh? Sigma fx is equal to be ma, so n is going to be equal to ma. Okay, بعدين sigma fy is أكيد going to be equal to 0 because it's not moving up and down. So f is going to be equal to w. What's f? F is equal to mu times n. صح? So w is equal to mg. So let's continue solving. So 0.40 n is going to be equal to m times 10 because g is 10 and mu is 0.4, right? So we know n is equal to ma. So 0.4 ma is going to be equal to 10m. You can cancel m with m, and you're going to get a is going to be equal to, take 0.4 to the other side, which is 25 meters second squared. Okay, question 2. I'm going to fly through these. Don't want to waste time. Cyclist of mass 70 on a bike 15. So these are the masses. 85, right? Because if you add them up, you're talking about the system. They gave us that A is equal to 0.8. So أكيد F is going to be equal to MA because they're saying the net force on the system. So you add them up. Okay, so it's going to be 85 times 0.8 and you get 68. أسهل من هيك ما في. A particle of mass 5 is projected at 3 meters per second up a rough inclined plane at 37 degrees. The coefficient of friction is 0.3. They want us to find the force of friction. Okay, we're going to start by drawing the FPD. أول شيء always when it's an inclined plane, draw your y and x axis. It's going to be going like this. This is going to be my y axis. Well, this is going to be my x axis, right? Okay. Then after you get this, you're going to draw your weight vertically downwards, right? نحنا we know it's going up. They're telling us free friction, but it's going to oppose the motion, so it's going to go like this. We know that there's the normal, and I think that's it. Yeah. Let's resolve this into wy, and let's put wx over here. Okay, let's see. We're saying here that it's projected up. They want us to find the force of friction. أول شيء they said, okay, well, they're telling us it's accelerating in part B. So we know that sigma fx is equal to a. This means that since we're accelerating, hold on. Yeah, we're accelerating to the left, and only the all forces we have are all to the right. So actually, we should have it as how can I say this? نحن all our forces are to the right, but we're accelerating up the plane. So you can actually say, in other words, we're decelerating since your forces are to the right, but you're going up the plane, right? We're going up. So you can just say it's a negative acceleration. That's why they asked for magnitude. But anyway, sigma fx is equal to ma. So let's just say f plus wx. Since it's a negative acceleration, just say negative ma. Okay, and then you solve later. This is our first thing. Then we know sigma fi is equal to 0, right? Because it's not jumping up and down, it's just going horizontally upwards. So n is going to be equal to wy. Okay, wy is actually equal to, they told us the angle here theta is 37 degrees. Should have put that from the start. W is equal to mg, but the y component is going to be w times cosine 37. Why cosine? Because the angle is with the vertical, so you use cosine for the y component. So mg cosine 37. Okay. What are they asking? They're saying the force of friction. How much is it? Friction is equal to mu n. Okay, we have mu given, which is 0.3. And we have n, which is mg cosine 37. We know that m is 5 and g is 10. So it's going to be times 5 times 10 cosine 37. And let's put this on a calculator. Oh, I got a new PC, huh? So, not new PC. I formatted my old PC because my dumbass downloaded a virus. Yeah, whatever. Okay, so I had to. Oh, do I have scientific? Okay, trig. Okay, I have them. So 0.3 times 5 times 10 cosine. Oh shit! No. 0.3 times 5 times 10, and then times cosine. No يا أخي خلاص. So 22.5 times cosine 37. So cosine 37, put cosine. لا حول ولا قوة إلا بالله. 37 cosine times 22.5. How did I get 22.5? 0.3 times 50. لا 0.3 times 5 times 10. Yeah, 15. Okay, so 15. How did I get 22.5? So 15 times cosine. لا cosine 37 times 15. Okay, 12. I don't know why. I should download the calculator. I'll download it for the next video. So anyway, this is the force of friction. The magnitude of the acceleration. Okay, so this one obviously we can't use sigma Fy, but we can use it for the magnitude of acceleration. F plus Wx equals ma, right? طيب, F we said is 12. Wx is mg sine 37, right? Because the weight is mg and it's the x component, so we use sine because the angles with the vertical, equals negative ma, and then we substitute. So 12 plus mg, the mass is 5, g is 10, sine 37 equals negative 5a. So let's do this. 12 plus, okay, let's, I wish you do 50 sine 37. Okay, so 37, this is sine 37 times 50 plus 12, and then divided by negative, divided by negative 5. Okay, nice. 42 divided by 5. Okay, 8.4. Yeah, 8.4. Sorry for the calculator. Oh, it's a bit. I'm just solving these. You know how to solve. Okay, then the distance traveled by the particle before coming to rest. We have the acceleration. We have that it started at 3 meters per second, v node, and we have that vf is equal to 0, obviously, because it's at rest. We have a is equal to 3. We want x. We're going to use v squared minus v node squared is equal to 2ax. So x is going to be equal to v squared, the v final is 0, minus v, remember, we got negative 8.4 as the answer. So here if you get a negative answer, just make it positive. Minus v0 squared, so minus 3 squared over 2 times 8.4. It was negative, okay? Remember, we got a negative answer. So, minus 3, so you say, just cancel the minus with the minus. I'm just doing this because my calculator is shit. So, divided by 16.8. Yeah, so you get this. When you calculate this, you get this 0.5 to 1 decimal place. After the particle reaches the height position, it begins to slide down. The magnitude of the new acceleration is a2. Complete the following comparison using a sign from the table below. Think of it like this, okay? The next time you're sliding down and the inclined plane, the only thing pushing the هيدا would the only pushing the object down would be the x component of the weight وعندك الفriction over here, right? طيب, in the first case we actually had two forces causing the acceleration or the deceleration or whatever. Okay, so in this case we only had one. In the first case we had two. So obviously the first case A1 will have a larger acceleration than A2. Realize that we said magnitude, okay? So we don't care about if it's positive or negative, what direction it's going. What we care about is how much, okay? So obviously two forces will bring you more than one force, okay? Question 4, okay? Two particles A and B of masses 2 and 3 are connected by a string. Particle A rests on a smooth with the string taut and perpendicular to intersection. System is released from rest and accelerates at 4.5 meter per second squared. So take G equals 8, find the tension. Okay, B they said is 3, A is 2 kg, huh? Type. The tension. So I'm gonna start with both blocks. Obviously I'm gonna start with block A. Block A is just take. So we obviously have the weight. Let's just draw it. This is block A, and then for block B it's gonna look like this, right? Okay, let's put A and B. Okay, let's label these. Over here we're gonna put our weight for block A and our normal, and we also have the tension. They said it's smooth, so ما في شيء. Obviously if it's a written part, put your vector. Okay, for B, okay, you have your weight, you have the x component of the weight and the y component of the weight. You also have the normal and you have the tension. Okay, so the tension in the string. So let's start for block A. Our sigmas are the sigmas. Okay, sigma fx is going to be equal to 0. No, sorry. It's going to be equal to ma because it accelerates, right? So sigma fx is actually going to be equal to ma. What are my fx is just t, so t is going to be equal to ma. So t is going to be equal to the mass of A 2 times the acceleration 4.5, which is 9.0. Okay, so this is part A. The angle. طيب, let's continue. Sigma Fy, I don't think you need it. You don't need it, no. I'll continue to the next block. Sigma Fx here is أكيد also equal to Ma, right? Vector symbols. Sigma Fx, if it's gonna be moving down the plane, so أكيد Wx minus T is equal to the mass of B, which is 3 times acceleration 4.5. Okay, Wx is actually equal to mg sine theta, right? Minus T is equal to 3 times 4.5 is actually 13.5. Okay. The acceleration I got from here, by the way, huh? mg, mass is of B is 3, g is 9.8, sine theta minus t, which is 9, is equal to 13.5. So you solve this. Oh, I best believe my calculator didn't solve this. Hold up. Okay, guys. So it was such a pain in the ass that I had to download it because it actually was pissing me off. Divided by 3 times 9.8. Then do shift sign. You should get 50. Yes. Okay, way better. Wallah, calculator saves so much time. Two particles of masses m3m, inextensible string, longer rough surface, accelerates at 6, so it's important. Coefficient of friction is 0.6, so mu is 0.6. Tension and F. So they want the tension in the string and the force F. Okay, we're gonna start with the block M, okay? And I'm also gonna draw 3m. Okay, so we're gonna put this 3m, and this is m. Okay, let me put the weight. The weight here we're gonna just call it mg so we don't confuse, and we also have normal. We obviously have the tension and we have friction, right? Friction, why? Because we're moving it to the right and they said it's rough, so obviously the friction will oppose. Here the weight is actually 3mg, right? Uh, the normal force, and you're pulling it to the right with the force F, and what's stopping it is you have some tension and you also have friction. Now here's the thing, people say, why is tension going to the left? And imagine you have a string, you pull this block, you pull the string, obviously it's going to drag m to the right, yeah, but also to prevent itself from collapsing, it's also going to drag 3m to the left. Okay, so this is the FBDs. We're going to start here. We're going to start with sigma Fy. Obviously, it's going to be equal to 0. So mg is equal to n. Okay. Then sigma Fx equals ma. So tension. It's accelerating to the right, obviously. So tension minus friction is equal to the mass times acceleration, which is 6. Okay. Okay. We can actually find friction because they're first asking for the tension, right? To find friction, you guys know friction is equal to mu n, right? Mu is 0.6, and here we found it as mg. Okay, we said it's mg. By the way, and you can skip this step completely. Just substitute f with mu n equals 6m. Okay, and you're gonna get mu is 0.6, n is mg, the mass is m, right? G هي 10 equals 6m. Solve this equation, you're gonna get this is 6m, so minus 6m take the other side is gonna be equal to 12. Okay, next here, so لقيت التنشن this is 12. هلا بدي force F. Okay, force F, again we're gonna just continue here with sigma Fy equal to 0, so n is gonna be equal to 3mg, right? How about sigma Fx? It's gonna be equal to ma because we're accelerating to the right. So F minus T minus F is equal to ma. So again, the mass of this one is 3m, acceleration is 6. Okay, T لقينا it's 12m. F is mu times n equals to 18m because 3 times 6. So F minus 12m minus 0.6 times n, in this case is 3mg. Don't confuse it with the n from here because they're two different objects, huh? So 3mg, so 3 times the mass, which is كمان 3m. No, wait, sorry. What am I doing? N is equal to 3mg. I should just copy this by itself. 3m, g it's 10, right? Okay. Equals 18m. Okay, so F minus 12m minus side 36 to 18m equals 18m. 36, 12, 48. Hey, so you're gonna take everything to the other side. You're gonna get 18m. 18, 36, 36, 12 is gonna be 48m. Okay. I should pick up the pace right. Oh, 17 questions. Damn. Okay, a body of weight 30 newtons lies on a horizontal table. The body is gently pulled to the right using a string inclined at 30. The tension in the string is 18 newtons. Assume the body moves with constant velocity. Constant velocity يعني sigma F net is equal to 0. Okay, طيب. Because there's no acceleration. Okay, we're gonna draw the FBD as سريع, but it's very easy. You have the weight obviously acting downwards, and you have the tension هيك 18 newtons, they said it makes 30 degrees. عندك أكيد ال normal. Okay, the magnitude of the friction exerted by the table on the body وبدهم magnitude of the normal. So I'm gonna start أكيد, we're putting it to the right in friction هيك, let's resolve this t into tx and ty. Okay, let's see. Sigma fx is 0, يعني tx is equal to f. Tx is t cosine 30. Why cosine for x? Because angle is actually with the x-axis. Equals f. Okay, معناتها t cosine 30 هي hold up. It's 18 cosine 30, which is should be 15.6. Let me see. 18 cosine 30. Yeah, 15.6. طيب, how about so f is equal to 15.6. Sigma fy كمان is equal to 0, right? So ty plus n is equal to w. صح. Okay. ty هي 18 sine 30. N here we're trying to find it. W is equal to mg, right? Oh, they gave it actually weight is 30. Okay, so akid you're gonna get n is equal to 21. Solve this equation. I won't solve it for you. You know how to solve. Okay, you'll get 21. I know. It's obvious. Okay, a cart stops eventually. So what makes it stop? Akid friction, and friction converts kinetic energy into TE thermal energy. A block of mass 6 kg is pushed along a rough horizontal surface. The coefficient of friction between the block and the surface is 0.5. The pushing force needs to accelerate the block at 4 meters per second squared. F is equal to ma. Okay. In this case, actually, you know what? I'm not gonna use this. I'm gonna use the proper professional method. FBD. انت it's 6 kg فعندك الويت. Imagine I label them y and x. ماليش خلق. So you have the weight. How you're pushing it to the right take with a force, right? أكيد في friction pulling it back. Okay. Yeah, sorry. You have F here pushing it to the right, friction opposing it, weight down, and of course it's on the surface, so on. Okay, we know that sigma Fx is equal to the mass times acceleration, because we want it to accelerate, right? So sigma Fx, since we're accelerating in the direction of the force, it's going to be F minus F equals to the mass 6, acceleration is 24, right? So we're missing this friction here. Now we want to know the force. We need no friction. They gave us the coefficient. You know, F is actually equal to mu times n. So we need this n. So I actually should have started with saying sigma Fy is 0. So that means n is equal to W, which is equal to mg, which is equal to 6 times 10, which is equal to 60. Okay, so F, the friction, is going to be equal to 0.5, which is the mu, times 60, which is 30. So you're going to get F minus 30 is equal to 24. Why did I put here 6? This is 4 inside. And when you multiply them, you get 24. I don't know why I wrote it like that. So you get 24. So F is equal to 30 and 24. It's 54. Okay. 9. The pulleys below are massless and frictionless. It's given that M1 is 5 and M2 is 2. The acceleration of M1 and that of M2. So when it's released, what's going to happen? Okay. أول شيء we're going to say that acceleration of this object is going to be equal, we're going to call it A2, it's equal to 2 times A1. You're going to need this later. You don't need to know it, but you'll see it in the answer actually. Whenever you have an object having 2 pulleys, that means the accelerations are spread out. Okay, so it's going to have less. Think of it like that. Or كمان if it has 1 pulley, يعني all of the acceleration is going to be concentrated at 1 pulley. That's how I memorized it. Okay, anyway, let's start with M1. Akid you have the weight. We're going to make this, they're actually only vertical. I don't know why I'm drawing them like this. Okay, they're vertical. So I'll start with M1 on the left and then M2 on the right. Okay, since it's vertical, you have the weights, obviously. M1 is going to be, let's call it, the weight is 5 times 10, so 50, because mg, right? I'm just making my life a bit easier. And up you have, here's the thing, up you have 2 tensions. Okay, why 2? Because 1, 2. Okay, on, I have obviously the weight, which is 2 times 10, which is 20. Up, I have only 1 tension, because it's 1 cable. Okay, طيب, what do we know? We know that they accelerate. Okay, we're going to assume, obviously, and actually, they gave it was the direction of acceleration is downwards. So for block A, or M1, we know that sigma Fy is going to be equal to Ma, right? Fy, since going down, yani 50 is greater than the 2t, so 50 minus 2t is equal to the mass of it, which is 5A. Okay, let's call this A1. It's very important. Here, since we're accelerating upwards, t minus 20 is equal to Ma, right? We're still using the same rule, Ma. So t minus 20 is going to be equal to m, the mass, which is 2a. Okay. We can find an expression that we can call this a2. Okay. This is the thing. If you have 3 unknowns, you can't solve. That's why we have to use the fact that a2 is equal to 2 times a1. Okay. So we're going to see 50 minus 2t is equal to 5a1. Wait. Yeah, okay, whatever. Let me just erase what I did here. We said that a2 is equal to 2a1, so I need to know what a2 is, so I can substitute it. Or you can actually just put it here, 2 times a1, right? So t minus 20 is actually equal to 2 times A2, which is 2A1, right? So you're going to get t minus 20 is equal to 4A1. So this is your first equation. Now you can actually solve because you have A1 here and you have it over here. Okay, let's find an expression for t. T is going to be equal to 4A1 plus 20. You take it over here. You can say 50 minus 2 times t. So 4A1 plus 20 is equal to 5A1. Hella 50 minus 2 times 4 is minus 8A1. Minus 2 times 20 minus 40 equals 5A1. تاخد ال 8 لهون, you're gonna get 13A1 is gonna be equal to 10. You're gonna get A1 is gonna be equal to 10 over 13. Okay, we don't calculators. A2 قلنا 2A1, so A2 is gonna be equal to 2 times 10 over 13, which is equal to 20 over 13. حلينا من دون أي calculator. Okay, كل شيء, all of it in your head is the best way to solve it in my opinion. But يعني, of course, if you have a calculator, use it. Question 10. خلص يا man. Block A, mass 3.5, incline 30 degrees, light string A to B, mass 1 kg. So هيدي B is 1 kg, هيدي A هون. I don't know, I didn't label it. The string passes over a smooth pulley. The system is released from with the string taut and the hanging part vertical. What is the acceleration? This actually comes copy paste in the exam, so it came in the final كمان. The acceleration of A. So for this one, I did it very easily. It took me maybe 2 minutes. I drew the FBD for A. I did هيك. Obviously the weight is going to be down like this. Why is FBD like this? Enter start by drawing your x and y axis. Look how it looks. Just copy it over here. Okay, so this is my weight going down. وأكيد I'm gonna have aero smooth, فما في شي friction. وأكيد I have the normal. That's it. في tension كمان. أكيد obviously tension acting to the right because of the string. عندك ال WY هون وعندك كمان ال WX. Okay, this is your FPD. For the other one B عندك بس vertical because it's hanging freely. أكيد عندك ال tension pulling it up وعندك ال weight pulling it down. هو ال weight هون وعندك ال tension هون. طيب, we know that the system is released from it accelerates. Okay, we know to accelerate. So this is the thing. Many people got this wrong. Haram, I felt bad, really. You can just do trial and error, wallah. But here's the thing. It's very easy. We know to accelerate. So I'm just gonna go straight to sigma of x is equal to ma because I don't have friction. Okay, that means here we don't know if it's going down or up. I'm gonna start with up because it's wrong, and I want to show you that what to expect if you get something that's wrong. So انت استردنا you don't know. Say you don't know. Say you think it's going up for some reason. Okay, you say start t minus wx is equal to the mass of A, which is 3.5 times A. Okay, wx هي m الانجل هون 30 wx هي الماس times g times sine 30 equals 3.5 A. So you're gonna get t is equal to t minus 30 17.5 A, if you solve this on a calculator, equals 3.5 A. And you're going to get T is equal to 3.5 plus, you're going to get 24 A. Okay. Then over here, since this is going up, يعني W is greater. W هون is equal to mg. Okay. What's the mass? 1. G is 10. Okay. So 10 minus T is equal to the mass times acceleration, because remember we're using sigma fx equals hon sigma fy, sorry. It's here I'm using sigma fy. It doesn't matter. Here it's fx, but here I'm doing sigma fy equals ma. It doesn't change anything, but if this is written, obviously you have to say it. Anyway, we're going down, صح? So w is greater than t. Okay. W is equal to mg. T is equal to 24a, right? To the mass 1 times a. Okay. So you're gonna get here, hold up. Okay, whatever. W minus T equals M. I don't know. I feel like I'm doing something wrong. But M is 1, G is 10. Still feel like I'm doing something wrong. بس يلا. Minus 24A is equal to 1A. So you're gonna get 10 is equal to 25A. So A is gonna be equal to 10 over 25. See, I did something wrong. I definitely did something wrong. Yeah, okay, I just saw what I did wrong. I might have autism, guys. Um, basically, over here, أنا أهبل. I don't know what I'm doing والله. I don't know how I wrote 17.5a, but when you calculate this, you get 17.5. بس ما بعرف, I don't know why I wrote a, بس هيك إنه you know sometimes واحد بتيس معه. Okay, you take 17.5 to the other side, so you get this is your expression for t. Over here يا أخي it's obviously substituted wrong. W is mg عادي mg minus t, which is 3.5a plus 17.5. Okay, you distribute is equal to the mass times acceleration. وظبطها. Mass is 1, g is 10. Minus 3.5a minus 17.5 equal to the mass 1 times the acceleration. قلنا we don't know it, right? طيب, so هيطلع لك 1 times 10 10 minus 3.5a minus 17.5 equals a. Okay, and you're gonna get minus 7.5 is equal to 4.5a. If you divide هلا, you're gonna get you're gonna get negative 1.67. Negative 7.5 divided by 4.5, you get negative 1.66667. So negative 1.7. So here's the thing. Enter when you get a negative answer, that means enter you probably got the correct answer, but you took the direction of the acceleration to be wrong. So since I got a negative answer, that means the acceleration is not in the direction I chose it to be. I chose it to go up. It means I have to go back, I have to resolve and do it again. Instead, we're gonna go down. We chose up the first time. So we're gonna do wx minus t is equal to ma, because we're using sigma fx is equal to ma. Okay? Wx minus, okay, wx here what? mg, I'm gonna mg sine 30. So mass 3.5 times g10 times sine 30, which I told you it was 17.5. Minus t equals the mass times acceleration, so 3.5 a. Okay, so let's find the expression for t. You're gonna get to 17.5 minus 3.5 a is equal to t. Okay, so this is your expression for t. طيب, sigma phi equal to me. Now instead of going up, instead of going down, taking the weight greater than tension, we're gonna take tension greater than weight and make it go up, right? So t minus w is equal to ma. T, we said it's this 17.5 minus 3.5 a. W, we said it's mg. Mass is 1, g is 10. So 1 times 10 is 10 equals to the mass 1 times a, which again we don't know, we're trying to find, right? So 17.5 minus, okay, 17.5 minus 10 is 7.5. Take it to the other side, we're going to get 4.5 a. And now when you divide, you're going to get positive 1.67, which is the same as 1.7. What direction will you take? We took it to go down the plane. Okay. Question 11. Okay, this one came copy paste in the exams. If you want to memorize answers, you can go ahead in case it comes. But over here, we're pulling and basically want to see how much is the force of friction. If you realize we're increasing the force and it still doesn't move, it only began to began to move over here at this point. So that means how much force did we have to exceed? We had to push 1.5 newtons to push. What does that mean? If I start pushing and there's no motion, that means this there's a certain force resisting my force, right? That's stopping our object from moving. And that force, what do we always call it? We call it friction. So how much was it resisting it for? How much is the friction here? When you say how much is friction, that means how much did it resist? And until how much? Until it's خلاص, you know, I ain't going to resist you anymore. Okay, 1.5. Okay, over here at 1.5. The mass of the block to one decimal, if you don't know, by the way, 2 minus 1 is 1, and you have 5 spaces. So 1.2, 1.4, 1.6. In between 1.4 and 1.6 is 1.5. The mass of the block is equal to what? You take any point and just do F is equal to MA. ما بدها هلا. Okay, so over here, let's take, I don't know, يمكن, I don't know, any, sorry. You can't just use F equals MA. You have to use sigma Fx is equal to MA. Okay? Even though you'd say, oh, what's this guy saying? Remember that we're talking about the force of friction. They asked you to find it for a reason. Okay? Because you had to push a force to overcome the frictional force and then another force to get the acceleration, right? Let's take myself this point here at 2. We have over here 2.5. Because each blank is 1, so 1, 2, between 2 and 3, 2.5. Okay, so at 2 newtons, I get 2.5 meters per second squared. If you just divide 2.5 F equals MA and divide 2 by 2.5, you're going to get 0.8. And why is that wrong? Because it has to be sigma of x. Always add up forces. if there's no friction قالوا لك smooth floor انه عادي خلاص you're applying a force, that force solely is getting you the acceleration. But here you have to remember that it's rough في friction. So what do? You have to do 2 minus 1.5 is equal to m. M we don't know it, a is 2.5. So m is going to be equal to 0.5 over 2.5, which I did in the calculator. I got 0.2. Okay, the coefficient of friction. Give it like a coefficient of friction. We know friction is equal to 1.5 n. And you know friction is equal to mu times n. Okay, n is the same as the weight because we're on a horizontal floor, right? So it's mu times mg. Okay, mu we're trying to find it. M هي الماس تبعتها which is 0.2, g it's 10. Oh, they said 9.8. Okay, how do you find mu? You just take قلنا friction 1.5, so 1.5 divided by 0.2 divided by 9.8. 1.5 divided by 0.2 divided by 9.8 وبيطلع لك 0.77. Okay, to 2 decimal place. Question 12. The block of mass 300 grams is held in place on a smooth inclined plane by rough horizontal floors. F equals 10 newtons. The angle at which the inclined plane is elevated to the nearest integer is how much? I guess we're gonna draw the FBD. Take the axis like this, axis like this. So it's gonna be like this. So the weight going down like this. Luna fi horizontal force horizontally. Okay, don't get tricked and put it at an angle just because it looks like it's at an angle. They said horizontal, I think, and we're gonna solve now and see. I'm not sure. I didn't solve this before, but logically it should be horizontal because they said horizontal. Okay, normal up. في ثeta هون وفي WX و WY. طيب if it's held in place somewhere, where they say it's held in place, يعني sigma fx is equal to 0. Sigma fx is F is equal to Wx. يعني the force 10 is equal to Wx, which is mg sine theta. So 10 is equal to the mass 0.3 times g, which is 10 times sine theta. And yeah, you can find theta from doing this. So just do 10 divided by 3. 0.3 times 10 is 3. So 10 divided by 3 and doing shift. So, oh. Wow. Hold up. Hold up. Okay, guys, so basically I did this one wrong. Okay. Apparently, because like I love mechanics. When I say horizontal force, it doesn't mean the force is horizontal. Okay, what's actually happening here is that this is the y-axis, x-axis, right? Easy peasy. You have the weight going down like this. So here's the thing. The force continues. Yeah. Guys, by the way, I paused the recording because I got hacked again, okay? And basically my friend who's very smart in computer science helped me in it. Okay. So this is how the force acts, huh? Oh, no, wait, sorry. Like, have it like this. Basically it goes like this. So it has this angle here with the same, and this angle is actually equal to the angle with the weight, okay? So basically, يعني the force over here, it goes like this, which is stupid, بس يعني يلا, okay? This is theta, this is theta. If it comes in the exam, they both have the same angle. ماشي. So أكيد you have fx, عندك fy, عندك wy كمان, عندك wx. Okay, عندك النورمال هون, وعندك yeah, that's pretty much it. There's no friction. طيب, since it's at rest, held in place, يعني sigma fx is equal to 0, صح؟ يعني wx is equal to fx. wx هي mg cosine theta. fx هي 10 sin theta. ليه 10 sin theta؟ لأنه they told us the force is 10. 0.3 yeah, 0.3 g is 10 cosine theta is equal to 10 sine theta. And you want to find what theta is equal to. So theta would be equal to, hold up, wait, no. Okay, yeah. So to simplify this one, what I'm going to do here is I'm going to divide by cosine on both sides. Okay, because remember, if you have sine and cosine, it's always good to keep the cosine down. So it cancels here, and you're going to get 3 is equal to 10 tan theta. So you're going to get tan theta is going to be equal to 3 over 10. So you're going to get theta is equal to inverse tan of 0.3, which is 3 over 10, whatever. Which is, yeah, I just realized what I did wrong. Astaghfirullah wa atubu ilayh. I changed the numbers up. Wx over here is mg sine theta. I don't know why I used cosine. Fx is mg cosine theta. Y, okay, look, for F, the angle is with the x-axis, right? For W, the angle, it's not here, it's with the vertical. I don't know why I drew it like there. Okay, so these are the same angle. So theta is here, theta is here. The angle is with the vertical. Okay, so that means for the x component, I use sine, and for this one, for the x component, I use cosine. F cosine theta. Okay, so you're gonna get 0.3 times 10, so 3 sine theta is equal to 10 cosine theta. Divide by cosine, you're gonna cancel this, you're gonna get that 10 theta, 3 times theta is equal to 10, so 10 theta is gonna be equal to 10 over 3, so you're gonna get theta is equal to inverse tan 10 over 3. Thank you to Mu'min Ala from Align for explaining this. 10 divided by 3, you get 73 degrees. Okay, the normal reaction on the block is how much? Again, you're just going to use now sigma Fy is equal to 0. N is going to be equal to what? You have the Fy and you have Wy, right? So Fy plus Wy. N is equal to Fy, which is F sine theta. Why sine? Because again, for F, the angle is with the vertical, with the horizontal. And Wy would be now mg cosine theta. Why cosine? Because the angle is with the vertical. Type F sine theta, so 10 sine 73 plus mg cosine theta, so 3 cosine 73. mg, I found the mg earlier. I'm not gonna do it again. So 10 sine 73 plus 3 cosine 73. So you get 10.2, 1 decimal place. Shaklan, they wanted me to use the answer from here. 10 sine answer plus 3 cosine answer. Yeah, that's still incorrect. That's still incorrect. 10.4. Oh, damn. Okay. Okay. Thank you to Yunus Muhammad Nader for helping out with this one. Assume now the inclined plane is scratched to make it rough. How would this affect the value of F to keep the block stationary? Obviously, to keep it at rest, if there's now friction, then you apply less force, right? Because the friction is also helping you out. Earlier, we didn't have friction here, so you actually had to apply more force to stop it from falling. Now you have to stop less force to stop it from falling. Several different values of the horizontal force F can be applied to keep it stationary. Which of the following is the best explanation for this observation? Static friction force can vary depending on the value of F. Okay, basically, memorize. Yeah. Okay, question 13. A conical pendulum is a long string with a bob of okay, this never comes though, so we're just gonna do it. Okay, the normal acceleration an is gonna be equal to, let me pull up the formula. So yeah, there's a formula for normal acceleration. It's 4 pi squared rf squared. Okay, so basically 4 times pi squared times the, I think that's radius 0.6 times the frequency 1.5, so 1.5 squared. Okay, it has to be in meters, that's why I put it like this. 4 times pi square times 0.6 times 1.5 squared. I should get 53. Yeah, 53. Okay, now the angle the pendulum makes with the vertical. So basically انت عندك this is your y-axis, this is your x-axis, بدنا هي الالpha. Okay, let's see. We're gonna draw the FBD. أكيد you have the tension like this, right? With the angle, we're looking for vertical, so I'm gonna use this. You obviously have, you don't have normal because it's not on the floor. You obviously have the weight. We can resolve this into tx و ty هون. Okay, يلا. It's set in motion. We have the acceleration. Okay, so that means we're moving. Sigma Fy is going to be equal to 0. So Ty is going to be equal to the weight. Sigma Fx is going to be equal to ma. Why is sigma Fy equal to 0? Because it's not going up and down, it's just rotating in a horizontal direction, horizontal manner. Okay, sigma Fx equal ma. What are my horizontal forces? Tx, it's my only force, equals to ma. Okay. Okay, Ty equals W. What is Ty? Since the angle we're looking at is the vertical, so that means for Y, I'm going to use T cosine alpha equals to the weight mg. The mass is 0.2. Ug, they said use 10. Okay. For this one here, Tx, since the angle is with vertical, the x component is going to be sine alpha equals to the mass 0.2 times the acceleration, which we found as 53. Okay. They want us to find the angle the pendulum makes with the vertical. Okay, so we have two equations. We have this t cosine alpha is equal to 2, right? Because 0.2 times 10. And you have t sine alpha is equal to whatever this is, right? We can rewrite, this 0.2 times 53. We have two equations. We can find an expression for t, but I want always, if I have cosine and sine, to have cosine down. Okay, so how can I make cosine down? Over here, I can just divide by cosine, so it's gonna be t is gonna be equal to 2 over cosine alpha. So here, instead of t, I can put 2 over cosine alpha times sine alpha is equal to 0.2 times 53. Sine over cosine gets you tan alpha. So 2 tan alpha is equal to 0.2 times 53. But let's solve for alpha. You do 0.2 times 53 divided by 2. So 0.2 times 53 divided by 2. Because I divided by the 2 on the other side, huh? And then you do shift tan of this. You get 79 degrees. Okay. Hala, you can find the tension. We know that tension is equal to 2 over cosine alpha. So T is equal to 2 divided by cosine of what I just got now. 2 divided by cosine 79. I need to put the brackets. 10.4 to the nearest integer, 10, right? Okay. Question 14. If it loads, when it loads, a person of mass 60 kilograms stands on the bathroom scale in an elevator. The acceleration, okay, bro, what? What? Okay, so I got the question back. They gave us that g is equal to 9.81. What's the weight? W equals mg. So 60 times 9.81. And you can find it. Okay, rank the readings on the bathroom scale for the instance label. When the reading is highest than 1. If two readings are identical, give them the same mark. Okay, when is it the highest? Obviously, if you're accelerating upwards, it's going to be the highest because there's going to be more weight pushing it down, right? So this is the highest. Then, once it's going to be weaker than that, when it's moving uniformly upwards. Elevator decelerating at 1 meter per second while moving upwards. Okay, it's moving upwards, but it's decelerating. Okay, so you can still count it as if, how can I say it? It's not equal to accelerating at 1 meter because this is heavier. This is actually, it's weaker. It's weaker than moving uniformly. And this one, it's weaker than this one because it depends on the acceleration. If you're moving uniformly upwards, then A is equal to 0. Here in this case, A is equal to positive 1 because you're going up. A moving uniformly downwards, then A is again equal to 0. A decelerating at 1, so A is negative 1. Here A is negative 2 because it's while moving downwards 2. Okay, the one with the highest acceleration is the highest. Okay, so this is the highest, so this is 1. The ones, we have 2 where they're equal to 0, so they're both 2. Okay, and then I have one which is negative 1, so that's the next, smallest, so 3. Then smaller than that is minus 2, so that's 4. Okay, question 15. I hate this question so much. Which of the following is the free body diagram of the block of wood? Akid, if it's an inclined plane, it's gonna be like this. Oh shit. It's gonna be like this, right? And like obviously the weight going downwards. Sorry. And like obviously the weight going downwards and the normal going up like this, right? They said friction. The rough, yes. So Akid there's gonna be friction. Okay, what did they do? They rotated it. This is the original Watfa method that for some reason teachers go against. I don't know why, but they go against. But anyway, this is the correct one. The coefficient of friction of the block of wood is how much? Okay, I won't draw the ABD because it's drawn here, okay? But I'll just fix it, try. So this is why. Yeah, I'll just draw it. Just put the front in the back. MG. And then here I have normal, here I have friction. Okay, the angle, okay, here is obviously going to be the same as the angle here. Okay, the angle here, you have opposite, you have adjacent. So tan of this angle is going to be equal to 3 over 5. So this angle here is going to be shift tan 3 over 5. Okay, they won't give you a triangle with sides unless they want you to actually find the angle. So it's going to be 31 degrees. Okay, I don't see anything else that I can use over here. Yeah, all the other forces are proper. They said that it's moving uniformly, so A is equal to 0. Okay, so sigma fx is equal to 0. What are, I have W, I put this into Wx and Wy, huh? So Wx is going to be equal to F. Wx is going to be mg sine 31 is equal to F, which is mu times n, right? Type. M, we don't know how much it is. Okay. Yeah, so we need to continue. Actually, need to solve this. We need n. So let's do sigma fy now. Sigma fy is going to be 0. So n is going to be equal to wy, and that n wy is equal to mg cosine 31. Okay, so instead of here, I'm going to substitute mg sine 31 is equal to mu times n, which is mg cosine 31. You can cancel mg with mg, and I can take this cosine there. So tan 31, because when I divide by cosine here, sine over cosine will become tan 31 is equal to mu. So I just do tan of this 0. I'm stupid. I don't know how to do math, guys. Tan is opposite over adjacent. I used hypotenuse. I don't know why. So opposite over adjacent would be 3 over 4. So tan alpha is going to be equal to 3 over 4, which is 0.75. So I should have, oh my god. So I should have used it, shift tan 0.75. I should have used it as 37 degrees. Okay, fix it as 37. We will get the correct answer. Okay, if you put 37, fix this to 7. Okay, tan 37, if you do tan of this, you get 0.75. Okay, the block of wood is now placed on the 3-meter side of the prism over here. What's the acceleration of the block? They're saying now it's gonna accelerate, right? Let's draw the new FBD for it over here. Okay, you're gonna have this is the y-axis. If the block is here, this is the y-axis. This is the x-axis, right? So hick. This is y. This is x. Obviously, the weight is gonna be like this, with the angle between it and the vertical. Let's see. It's how much is the angle over here? Is gonna be over here. The angle over here opposite over hypotenuse, or let's just use opposite over adjacent. Opposite over adjacent. So 4 over 3. So tan is equal to 4 over 3. So how do I find the angle? Shift tan of 4 over 3, you get 53.1. Okay, so here 53, sorry, here between it and the y-axis, right? 53.1 degrees. Okay, you have obviously wy wx وعندك normal وعندك كمان friction, right? Okay, sigma fx is going to be equal to ma, right? So wx, since it's accelerating down, wx minus f is going to be equal to ma. Sigma fy is equal to ma. That means n. So wait, no. Sigma fy is going to be equal to 0. It's not bouncing up and down. So sigma fy is equal to 0. So wy is equal to n. It's just moving down the plane, right? You might think, oh, no. It's not moving up and down, just moving horizontally down. Okay? So let's see. Wx minus f equal ma. Wx is mg sine 53.1, right? Minus f. F is mu n, so 0.75 n is equal to the mass times acceleration. Wf is equal to n. What's wy? Wy is equal to n. What's wy? It's mg cosine 53.1. Okay, so هون بنحط mg sine 53.1 minus 0.75 mg cosine 53.1 is equal to ma. You can cancel m. Okay, you're gonna be left with you can solve this. G sine 53.1. G is, they said, use it as what? 10. Okay, so 10 sine 53.1 minus 0.75 times 10 is minus 7.5 cosine 53.1 is equal to the acceleration. So you just solve this. You can just solve this equation. 10 sine 53.1 minus 7.5 cosine 53.1. You get 3.5. Okay, let's finish up these last two questions. Rather easy. Okay, a block of mass 2 is placed on block of 8, which in turn stands on a frictionless table. The upper block is pushed rightwards by a horizontal force of 5. The blocks remain stationary. The acceleration of the systems of the block relative to the ground is what? When we say that the blocks remain stationary relative to one another, and they're still stuck to each other. So you're pushing this, they're still stuck, and akid this one's gonna move. Okay? What is the acceleration of the system of the blocks? F is equal to ma. Okay, you're talking about the system. The mass is 2 plus 8, 10. Or acceleration, we don't know, right? The force, we pushed it with is 5. So acceleration is going to be equal to 5 over 10, which is 0.5. The friction force between the system of the blocks is how much? Okay. I don't know if I explained part A. I think I explained part A. The acceleration of the system of the blocks relative to the ground, you can use F is equal to ma. A is going to be equal to F over m, so it's going to be 5 over 10, which is 0.5. That's easy. So it's accelerating at 0.5. Type the friction force between the system of the blocks. Here you have a block of 2 kg, okay? You have a block of 8 kg. The 8 kg block is pushing the top block to the back, right? So it's pushing it with a force. We don't know how much it is. The friction force is equal to the mass times acceleration. Because it's the mass 8, right? It's pushing it back and it's accelerating at 0.5. So this is accelerating to the right at 0.5. This is pushing it back with the same amount, okay? This can't be 5 because some of the force is actually put in to move the whole system to the right, okay? So this 4 newtons is the friction force. Let me show you. We know that the 8 kg block is pushing the top one back with the acceleration of 0.5. So F is just going to be equal to 4 newton. And then the coefficient of friction, how much is it? F is equal to mu n, right? So mu is going to be equal to F over n. With the normal force in this case, the normal force is actually going to be equal to the weight of the top object because we're talking about the top object here, okay? You're looking at the top block, right? Yx. The normal is going to be equal to the weight, right? Because it's not jumping up and down because sigma Fy is equal to 0. It has the weight going down with the normal going up. So that means the normal is equal to the weight, okay? The coefficient of friction between the blocks. And you got the friction is 4 newtons. The coefficient of friction بين top object, right? So sigma Fy equals 0, so that means n is equal to W. So n is equal to mg, which is equal to the mass of it, 2 times 10, which is 20. So you're going to get the friction force 4 divided by 20 is equal to 0.2. So, to sum this up, the acceleration, you take the whole system, because they said system. The friction force between the system of the blocks. What's pushing it back? 4 newtons. So that means the friction is 4 newtons, okay? So you look at the one that's pushing it back, you do F equals ma. With the acceleration you found. With the coefficient of friction between the blocks, to find the coefficient of friction, you want to see the block that's undergoing friction. So friction is equal to the mu over n, okay? Is mu n. Mu is going to be equal to the friction divided by the normal force. Which normal force do we consider? We consider the block that's being frictionized, okay? You can say that. Question 17. 2 blocks of masses 2 and 3 are connected by a string which passes through 2 light frictionless pulleys. The 3 kilogram block is placed on a frictionless table. Initially, both blocks are stationary. What's the acceleration of the 2 kilogram block and the 3 kilogram block? Well, let's start with this one here. 2 kilogram block, we're going to start with the FPD. Tabata. Okay, weight goes down, tension goes up. Okay, initially both blocks are stationary. Okay, so sigma Fy is equal to 0, so T is equal to W, which is equal to the mass of it times G, so 2 times G10. So T is equal to 20. Okay, here for 3, you have the tension to the left. They said it's frictionless, so عادي. Weight down, normal up. Okay. They said it's accelerating. Wait, shit. Sorry. They said acceleration. So, yeah, of course. Should be equal to ma. Sigma Fy is equal to ma. Okay. You need to know which direction is it falling. You know, is it going up or is it going down? Yeah, obviously this one's standing here, so this one's gonna pull this one to the left, right? So it's gonna go down, so W is greater than T equals ma, right? W is equal to 20, we just found it, minus T is equal to the mass 2a, okay? For this object, the 3 kilogram object, this is the FPD, it's going to the left, so T is equal to ma, so T is equal to the mass of it, 3a, okay? We need to find an expression for T, it's 3a, right? So 20 minus 3a is equal to 2a. What does this mean? 20 is equal to 5a, so a is going to be equal to 4 meter per second square. Will they have the same acceleration? Because it's the same they didn't say in extensive string. Okay, but when they're both connected to the same amount of string, this is one string, this is one string. Don't say it's two strings, it's connected to one string. The other time when it was two strings was because it was like this. Okay, that's two. This is how it looks when it's two strings. Okay. The net force on the 3 kilogram object. What is the net force on the 3 kilogram object? Okay, the N and the W cancel out. Okay, the only force acting on it will be T, which is 3A, so 3 times 4, which is 12. The table is now scratched to exert friction on the 3 kilogram block. When placed on the table again, the block remains in a limiting equilibrium. What is the coefficient of friction? If it remains in limiting equilibrium, هلا في this friction force over here, right? F. So that means T is equal to F, because it's staying in limiting equilibrium, right? It's staying in equilibrium. So T is equal to F, because Y sigma Fx is equal to 0, la. You have this F here. So T is equal to F. Okay. Over here, sigma Fy is now going to be equal to what? 0, because it's in equilibrium. So we're going to erase this and fix it. Okay. Sigma Fy equal to 0. So T is equal to W. Okay. If T equals W, or T equals F, you can say W is equal to F, right? What's W? 20. 20 is equal to F. Okay, 20 is equal to, because we're looking for the coefficient of friction, so mu times n. What's n? N is equal to W here. We're going to call this W1 because we had to call this W1, right? So W1 is equal to F. Okay, here we're going to call this W2. N, what's it going to be equal to? W2, because sigma Fy is equal to 0, so N is equal to W2. I don't have to keep writing this. What's W2? It's mass of this second object times G, right? So 3 times 10, so 30. So N is actually equal to 30. So 20 is going to be equal to mu times 30. So mu is going to be equal to 20 over 30, which is 0.67. Okay. Just to recap, first one, we just did sigma Fy is equal to ma. You plug it in, solve system of equations, عادي. Now, second one, you have now friction, and they told you it's in equilibrium, so all the sigmas are equal to 0. Okay, so T is equal to F. Okay, and here T is equal to W. Since T is equal to F, T is equal to W, that means W is equal to F. And this W, if you do mg, you're going to get that it's 20. We found it earlier. With this F is actually equal to mu n. And to find it, you have to go back here. N is equal to W because sigma Fy equals to 0, so N is equal to W. And this W is different than this W. Okay, this W is equal to the mg here, so 3 times 10, 30. So it's going to be equal to N is equal to W2, which is 30, so N is equal to 30. So here for N, you substitute 30, so 20 equals mu 30. Mu equal 20 over 30, which is 0.67. Okay, thank you so much for watching. يعطيكم العافية, and good luck. I hope my PC doesn't get hacked again.